Okay, so this should be a quickish video about integration using tables and technology. So, frankly, tables are probably at this point mostly a thing of the past. A table of integrals is like, well, so for this class, I gave you a list of integrals to memorize. That's a very short table of integrals. There's a longer table of integrals in the back of the book where they have even more functions with just the antiderivative of this is this, the antiderivative of this is this. It's a very long list. It's more than you would ever want to memorize. And back in the day, and I guess these things probably still exist, but probably nobody really uses them anymore. There used to be entire books filled with just antiderivative of this is this, antiderivative of this is this, and people used to use it because back in the day, that's the best thing we had. Is you run into some horrible looking function and you have to find the antiderivative and you have no idea how to do it. These tables were very helpful. Because yeah, so as we're learning, I guess we just did partial fractions recently. Integration in general can be very difficult and time consuming, especially if you have to do the whole thing by hand. And even back in the day before we really had great computers and now artificial intelligence and all of that, we had to integrate functions that were more than we really wanted to deal with. And so we used tables of integrals. So that's about all I want to say about tables of integrals, because like I said, these days it's probably mostly a thing of the past. So let's talk about technology. So I'm going to show you a couple of things here. First, we have Maple. This is great mathematical software. It's available on many university computers, not all university computers, but there's some in the library that have it, and I think there's some computer labs on campus that have Maple. So here's Maple. I can go to start a new document. And recent versions of Maple are pretty user-friendly. We have this menu on the left. So let's say I want to integrate something. So I'll click this button and it puts something like this here. And I just have to replace this F with whatever I want to integrate. So let's say I want to integrate, okay, what should we start with? How about 1 over x to the fourth plus 1? This looks like something that we would do using partial fractions. It's a very hard version of partial fractions. There's a reason why I'm using technology to do this. I would really not want to do this by hand for sure. Let's see what it tells me. Yeah, just looking at what the answer is, this is confirmation that we would not want to do this by hand. Uh, the factorization of this polynomial, as innocent as this polynomial appears to be, the factorization is quite nasty. It's actually this times this. And how you find that factorization is not something that I really particularly want to talk about. Of course, the form of the answer is probably not terribly surprising. We have arctangents and natural logs, and that's what tends to come out of partial fractions. But the details are definitely not something we would want to do by hand. So this is an example of something that you would not want to do by hand, but you can easily do it using, say, Maple. All right, why don't we do something else? Let's do another one. Say I want to do, okay, 1 over e to the x plus 1, and I get a warning because Maple doesn't really like the letter E. I guess it looks like it did. Oh yeah, yeah, yeah. It's not clear that it really did the right thing. Like the number E, the natural log of E should just be 1, but Maple isn't really sure that I mean E. So let me try that again. Yeah, I was wondering what Maple would do with that. I suspect that it just wouldn't work at all. But here's a more proper way of putting e to the x. Maple likes us to put like exp of x. That means e to the x. Yeah. So actually, looking back at the first answer it gave, it pretty much lines up because the natural log of e is 1. It's just that Maple didn't really know that I actually meant e at the time. But for the second answer, Maple knows that e is really e. Anyway, okay, that was fun. Let's try one more. Let's do e to the x squared. So I put exp of x squared. Now this is one, let's see what Maple gives us. Yeah, it gives us something a bit crazy looking. What is this? So this antiderivative is not an elementary function. This is one of the most disappointing parts of finding integrals is that when if I give you a function that's built up out of like trig functions and e to the x and polynomials and stuff like that, like this, I have e to the x squared. X squared is just a polynomial, so this is what we call an elementary function. It's built out of the basic building blocks of polynomials and trig functions and logarithms and exponents and these common functions that we talk about. But just because this is an elementary function does not mean that its antiderivative is an elementary function. Its antiderivative is this, which this is a non-elementary function, this ERF of x. Uh, anyway, it's a thing, it's just not an elementary function. So Maple will give us something that appears to be an answer, but it's in terms of this function that we're not familiar with. Anyway, uh, okay. Maybe that's all I'll say about Maple at the time, because another thing I want to show you is Wolfram Alpha. This is just a website. You go to wolframalpha.com and then you're there. And one nice thing about Wolfram Alpha is it has this natural language option. It also has the math input option, and then it gives you this menu where you can like do integral signs and all of that stuff. But I kind of like the natural language option because I don't really have to worry much about syntax of like telling the computer what I really mean and having the computer be finicky and give me errors and all of that. I can just say stuff like integral of, I'll do an example that we did on Maple, 1 over x to the fourth plus 1, and just hit enter. And it tells me this, which looks slightly different from Maple's answer, but I'm sure it's equivalent. In fact, yeah, I think Maple told me that it was like this log over this, so it was sort of a less simplified version, but these are the same thing. And it gives me some more information. It can give me like alternate forms of the answer, and yeah. Okay, so why don't I, just for fun, yeah, I guess Wolfram Alpha predicted what I was going to ask, e to the x squared. And yeah, well, the answer looks exactly the same as Maple gave me. It's root pi over 2 times this crazy ERF function. Um, okay. So that's Wolfram Alpha. That's just a website. You don't need to register or anything for that. You can just go there and I really like it. Of course, since this is 2025, let me show you ChatGPT. I'm sure I'm not the first one to, I'm sure you're already familiar with ChatGPT. Professors are constantly worried about how do we deal with ChatGPT, but oops. Let's tell ChatGPT to do that. And yeah, frankly, ChatGPT is probably the giving us the best results of what we've seen. Um, oh, maybe, yeah, okay. Let me know if you'd like a detailed step-by-step breakdown. Ooh. Oh, no, it'll still tell me. Yeah, so it looks like, I don't know how much I really want to scrutinize this, but it shows a lot of work. It shows how to factor this polynomial, and it factors into things that look like what Maple and Wolfram Alpha were giving us. And then it gives us the partial fraction decomposition. I'm a little bit suspicious of this because these are irreducible quadratics. So I wouldn't just put an A on the top. I would put like AX plus B and then maybe CX plus D here. But okay. So it's solving for A and B. It's sort of showing the work. Oh, yeah, I don't like this at all. It's telling me A equals 0 and B equals 0. That's nonsense. Okay, so I take it back. Let's not trust ChatGPT too much. I knew that ChatGPT has given me some pretty wacky answers for like more advanced math, but I thought it was pretty good at calculus. Um, yeah, actually, th this is fairly bad. I don't like this at all. Um, let's try something else. 1 over each of the x plus 1. It's doing a substitution. It's rewriting the integral. It is, and then it stops. Yeah, actually, I'm disappointed in ChatGPT. It's all right for some things, but it's not really doing a great job for integrals. So yeah, maybe this is a good moral of the story that ChatGPT is not as good as I thought it was. Wolfram Alpha is very good though. Wolfram Alpha is legit and Maple is legit. So anyway,